Hi guys, in this section we are going to explain you different types of batteries. This topic is generally from the chemistry and name of the chapter is electrochemistry. Now as you see over here, the topic written over here is battery. Now what is battery? Arrangement of one or more cells connected in series. So when we connect two or more cells in series, then it is a battery. And battery is generally used in galvanic cell where the chemical energy of redox reaction is converted into electrical energy. That means in the battery, chemical energy converts the chemicals which are present in cells, they converts into the electrical energy. Now generally batteries are of two types, primary battery and secondary battery. Now we learn one by one. Now what is a primary battery? The primary batteries are those in which the cell reaction occurs only once. So all those batteries in which only one time a cell reaction occur and battery becomes dead after the use over a period of time. And after some time battery becomes dead. For example, we have a dry cells in our home like Leclanche cell, mercury cell, etc. All these are the primary batteries. That means when we use these batteries and when they become dead, that is one of the material becomes dead in that, we just replace that battery. We cannot reuse it, we cannot recharge it. So there are different types of primary batteries, for example Leclanche, mercury, etc. Now we study one by one. Now this is the picture of Leclanche cell. You can see over here, this is a metal cap. So here you can see this is a metal cap, okay, and this is carbon rod, that is cathode, okay. So this terminal is taken as positive generally, okay, and here on the base this is the zinc. Clear? So zinc is taken as negative. And inside this cell, there is a powder of manganese dioxide, carbon and ammonium chloride. So this is all filled with manganese dioxide, carbon rod and the ammonium chloride. So there is carbon rod goes on. Clear? Now we study different types of reactions which occurs in the Leclanche cell. At the anode, zinc metal releases the electron and changes into ions, okay, and at the cathode manganese dioxide and ammonium, they take the electrons and they convert like this, okay. So here the carbon rod act as a cathode and zinc plate act as a anode. So now here this is a picture of the commercial dry cell of the graphite. So in zinc container and the latter act as a anode, okay. Now next, mercury cell. Now we study the mercury cell. Mercury cell, these are generally known as button cell because they are of a small size and they have a shape like a button. You can see over here, this is a top and this is just a shape of a button. Now here also we have zinc at anode but at the cathode we have mercury in the button cell. So here zinc, the reaction goes like this. So overall reaction is zinc and this is mercury oxide and it converts into zinc oxide and mercury, okay. So now this is the anode cup, okay, and here this is the cathode. Now this is the separator between them and this is known as casket, okay. So here the reducing agent is zinc and the oxidizing agent is mercury second oxide. So you have to remember all these things. Now next, the cell potential is approximately 1.35 volt and it remains always constant during all over its lifetime. Because when it was dead, any of the material is finished, then the cell becomes dead and we have to replace for it. Now secondary batteries. Now we learned about the primary batteries, that means when the chemicals present in them are finished, and the battery cell becomes dead and we have to replace them. We cannot recharge them, we cannot reuse them. So these are the primary batteries. Now in case of secondary batteries, listen, see over here, secondary battery can be recharged by passing current through it in the opposite direction. For example, you have inverters in your house. They again recharge and they provide us the electric current. And the best example of secondary battery is the lead storage battery. And this is generally used in the automobiles in the inverters which we have at the home. You can see its picture. There are the caps from where we just simply fill the distilled water from these caps, and these act as a anode. Okay, and here this act as a cathode. Okay, now they are the grids, and in these we fill the sulfuric acid. Clear? They are the lead grids filled with lead oxide. Now overall reaction for the lead storage battery, that means there is a sulfuric acid. So lead storage battery, that means there is a lead. Lead means Pb, that is plumber. That's a Latin name is plumber. So Pb. So in this we have lead grids and lead oxide, which is filled in these lead grids, and there is a sulfuric acid in between them. Dark one is the lead grid, and dot dot dot, this is sulfuric acid. So these react with each other and they form lead sulfate and water. Okay, so as the name suggests, you see over again, as the name suggests, lead storage battery, so it contains lead and sulfuric acid, and they are generally used in automobiles and inverters. Something you have to learn, that is for example some reactions you have to learn. Now here this is a picture of nickel cadmium battery. Okay, nickel cadmium battery. So there are different roles which are present inside the battery. Positive separator, then negative, then positive, then negative, then positive. Okay, so that's why it is known as jelly roll, because there are different roles. So nickel cadmium battery. So nickel cadmium battery, so nickel and cadmium reactions are there. So cadmium reacts with nickel hydroxide and this form this and this, overall these reactions. Now next one, fuel cells. They are very important nowadays. Now we are going to study what is fuel cell. The galvanic cells which use energy of combustion of fuels like hydrogen, methane, methyl hydroxide, methanol, this is methanol, etc. is the source to produce electrical energy. These are called fuel cells. That means, listen over here, the cells which use energy of combustion of fuels. That means when we burn fuels, not wood, fuels, that means those fuels like hydrogen, methane gas, and then we get energy, then these are the fuel cells. These are the most successful fuel cells, and generally these are the reactions. There is a hydrogen and oxygen in the gaseous form to form the water. From here we insert hydrogen gas, here the oxygen gas, and there is an electrolyte. Okay, so here outside this is anode, and hydrogen gas goes outside. Okay, water we get the water. So this is a H2 and O2 oxygen is used, so we termed it as H2O2 fuels. So at the cathode, see over here, cathode means positive. Okay, so at the cathode, oxygen, reaction of oxygen occurs with water, it gives hydroxide. At the anode, this reaction, so overall reaction, hydrogen plus oxygen, it gives water. Okay, now what is the main advantage of fuel cell? The main advantage of fuel cell over batteries is that these are pollution free. That means all of the electrical energy, all the energy which we get from fuel cell, that was pollution free and highly efficient, where they are used for various purposes. Now the last one topic of this lesson of electrochemistry is corrosion. Okay, so actually the topic of the battery and cells are finished in this lecture, but I am also going to take the topic corrosion in this lecture. What is corrosion? Generally you see in your houses that if there is a door of iron, it is get tarnished sometimes. That means there is a layer of rust is deposited on that. So that's why that was the corrosion. So it is the oxidative deterioration of a metal surface with the action of its environment to form unwanted corrosion products. So this is not only concerned with iron. Corrosion can be on the zinc also. We get a green color tarnishing. So this is the oxidative deterioration of the metal surface. That means metal surface was distorted because of the oxygen. For example, the zinc surface gets distorted. For example, iron surface gets distorted, and as a reaction of oxidation occurs. Now this type of damage usually affects the metallic substances and they produce oxides, and then